Ever wondered how to protect AI models from being misused? Like a vaccine for machines. Today, we're diving into a groundbreaking approach called model immunization, a way to make AI models harder to trick while keeping them useful for good purposes. Let's break this down. So what's the problem? Open source AI models are powerful, but they can be misused. Think of it like a super tool that could be used for harm if not careful. Researchers want to immunize these models, making them resistant to harmful fine-tuning, while still working great for normal tasks. But how do you even define an immunized model? That's where this study shines. The key idea here is something called the condition number of a matrix. Don't worry, we'll simplify it. Imagine a puzzle. If the pieces are perfectly aligned, it's easy to solve. But if they're twisted, it's harder. The condition number measures how twisted a mathematical problem is. For AI models, a high condition number means the model is harder to fine-tune, exactly what we want for harmful tasks. To understand this, we need to look at Hessian matrices, which describe how a model's performance changes during training. By analyzing their condition number, researchers found that the angle between two datasets, pre-training data and harmful data, determines how easy or hard it is to tweak the model. If these datasets are misaligned, the model becomes immune to harmful adjustments. To make this happen, they designed an algorithm with special regularization terms. Think of these as training wheels that guide the model's learning process. One term increases the condition number, making harmful tasks harder, while another keeps it stable for normal tasks. It's like teaching a robot to be stubborn against bad instructions, but still follow good ones. They tested this on both simple linear models and complex deep learning networks like ResNet and ViT. The results? The approach worked surprisingly well, even where theory wasn't perfect. This means safer AI systems could be developed without sacrificing performance. This research isn't just about math, it's about building trust in AI. By understanding how models learn and resist, we're one step closer to responsible AI. Want to see the code? Check the link in the description. Thanks for watching, stay curious. Ever wonder why some AI models act like superstars, crushing tasks with ease, while others stumble over the simplest data? It all comes down to a sneaky little math concept called the condition number. Think of it as the stability score of a machine learning model. A high score, like a wobbly chair, small bumps send it toppling. A low score, more like a solid table, unshakable. Here's the thing, AI models are basically math equations trained on data. But when those equations are ill-conditioned, high condition number, even tiny changes in input, like a smudge on a photo or a typo in text, can mess up their predictions. It's like a recipe that works perfectly, until you accidentally swap salt for sugar. So how do researchers fix this? They're using a clever tool called ResNet, which acts like a digital vaccine for models. This technique tweaks the math during training to lower the condition number, making models more resilient. Imagine giving a model a stability boost, so it doesn't panic when faced with tricky data. Why does this matter? Well, think about AI in healthcare, self-driving cars, or even your phone's voice assistant. If a model's unstable, it could misdiagnose a patient, misread a stop sign, or fail to understand your command. By making models more robust, we're not just improving performance, we're making them safe. This research isn't just about numbers, it's about building AI that can handle the real world's chaos. Next time you interact with an AI, remember, behind the scenes, math is working hard to keep it strong and reliable. Thanks for watching. Stay curious, and let's keep exploring the future of AI together.